Okay, so today we are going to learn section 4.2. Section 4.2, solve the ordinary differential equation where one side is the exact derivative of a product and the other side it can be integrated with respect to x. Alright, so let's do a revision first. So in section 4.1, we learned separating variables method. So separating variable methods is for those kind of question like dy by dx equals f of x times gy. Okay, so we can separate the variables like 1 over gy times dy equals f of x times dx, and then we do integration on both sides. It will be integrate 1 over y with respect to y equals the integration of f of x times dx. Okay, so this is what we learned in section 4.1, and now we are going to learn section 4.2. So section 4.2, so it said one side is the exact derivative of a product. So let's recall product rule. So product rule, so the derivative of two functions, so df times g by dx, it equals f times dg plus g, keep g, and then df by dx. Okay, so it means that in this kind of differential equation, the left hand side or one side is the exact derivative of a product. It means that it is a sum of two terms, and these two terms can be written as a product, the derivative of a product. Okay, and the right hand side is function with respect to x that we can integrate, do integration directly. Okay, so this is type 2. Okay, so this is type 1 and type 2. So when you solve the problem, if we cannot use type 1, and we will try to use type 2. So type 2, so let's look at the pattern. Left hand side is a sum of two terms, and the sum can be written as a product of two functions, and another side is a function that we can integrate directly. Okay, so this is type 2. So when you do the question, your thinking is from step 1, and then if we cannot use type 1, we may think type 2. Okay, type 2. So this is the logic. Okay, so now let's look at example 5. So find the general solution of the equation. So firstly, let's observe the differential equation. You see that we cannot use separating variable methods to do this question, right? We cannot separate. One side is y only and another side is x only. Okay, so now we will, so step type 1 for type 1 we cannot use the method. Okay, and we have to choose type 2. Okay, so let's check whether the left hand side can be written as a product of the derivative of a product of two functions. So of course yes, so obviously x cubed is the original function and y is the original function also, right? So these two functions will be x cubed and y. So let's try. So dx cubed times y by dx. Okay, so you may also check it again. So firstly we keep x cubed, and then dy it will be dy by dx, okay, and then keep y, and then dx cubed it will be x to the power of 3x to the power of 2, okay. So it is keep y, and then dx cubed it is 3x squared, okay. So the left hand side can be written as the derivative of a product. So the right hand side is sine x only, okay, and then we multiply dx on both sides, so it will be sine x times dx, okay. And after that we do integration directly, so integrate directly, and the left hand side is x cubed y, and the right hand side is integrate sine, it will be negative cosine x and then plus constant c. So finally we should write the subject to be y, so y equals negative x to the power of negative 3 cosine x and then plus c times x to the power of negative 3, okay, negative 3. So this is question example 5. So here we use type 2, okay, type 2 again, record again. The left hand side is like this, or one side is like this, and this one can be written as the derivative of a product, okay. So this is example 5, and then let's move to the practice, exercise 4b. So for exercise 4b, so firstly let's observe the equation first. So obviously we cannot use separating variable methods, okay, so we have to use the second method. So let's check whether the left hand side can be written as the derivative of a product. So of course it is yes. So one of the function is e to the power of x, okay, because we dy here first, okay, so keep e to the power of negative x, and then another one we keep y, okay, y is the original function, and you may double check it again whether it is whether it equals the left hand side. So dy first and keep e to the power of negative x, and keep y and d e to the power of negative x, so it is negative e to the power of negative x, okay, so it is correct. So the right hand side is x times e to the power of x, okay, and then we multiply dx on both sides, so it will be d e to the power of negative x y equals x e to the power of x dx, and we do integration directly. Alright, so actually the left hand side is very simple, and look at the right hand side. So right hand side obviously here it is we should use integration by parts, because you see the integrand is a product of two functions, okay, so we use integration by parts to find the indefinite integral. So consider x e to the power of x, this one, and we have to let, okay, we should let fx be x, and g prime is e to the power of x, and gx is also e to the power of x, okay, so integration by parts. So the answer will be f times g, so which is x times e to the power of x, and minus df is 1, so keep g e to the power of x dx, alright, and then the answer will be x times e to the power of x minus e to the power of x plus constant c, alright. So this is the right hand side, And now let's check. So left hand side, we integrate left hand side, so the answer will be e to the power of negative x y equals x e to the power of x minus e to the power of x plus constant c. So finally the answer, we write the subject to be y, so y equals x times e to the power of 2x and minus e to the power of 2x and plus c times e to the power of x. So this is question 2, all right? And now let's move to question 4. Question 4, let's check. So firstly, we cannot use the first method, separating variables method, to do this question. So we have to use second method. So one side can be written as, check whether the left-hand side can be written as the derivative of a product. So of course, yes. So one of the function is 1 over x and another one is y, okay? So d 1 over y times x by dx, you can double check whether it is true or not, okay? So actually it is true, and equals e to the power of x, okay? So I think you should double check your answer, okay? So dy and keep 1 over x, and then plus keep y and d1 over x. d1 over x will be negative 1 over x squared, okay? It will be negative 1 over x squared, all right? So this is the left-hand side. And now let's multiply dx on both sides. So here is y over x and e to the power of x dx, and then integrate. Okay, so finally the left hand side is y over x and right hand side is e to the power of x plus constant c. So y just equals x times e to the power of x plus c times x. Okay, so this is question 4. Okay, and now let's move to question 8. So find the general solution of the differential equation for x greater than 1. Okay, so let's check. Here, firstly, we cannot use separating variables method, okay? Because we can write one side is y only and another side is x. Okay, so now let's check here. You see one side is a sum of two terms, so we may think whether it can be written as the derivative of a product. So of course, yes. So one of the function is ln, another one is y, okay? So now let's try. So it can be written as y times ln x, the derivative of y times ln x, and you may double check. So we dy first and keep ln, keep ln, and then keep y and d ln is 1 over x, okay? So it is correct. So now let's copy the right hand side. So it will be 1 over x plus 1 times x plus 2, okay? And multiply dx on both sides. So it will be 1 over x plus 1 times x plus 2 and then dx, okay? And do integration. So here, pay attention. It is better to write it as y times ln x, not ln x times y, because I may regard it is ln xy, okay? Ln xy, so it is better to write as y times ln x, okay? But if you want, you may write as ln x times y, okay? Pay attention to the written format, okay? So here, let's continue. So this will be the integration of 1 over x plus 1 times x plus 2. Okay, so left hand side is very simple. It is y times ln x, and right hand side is not. Okay, so for right hand side, as you know, it is a fraction. So we have to recall the way we have learned for integration. The first one is integration by substitution. The second one is by partial fraction. The third one is by parts. Okay, by parts. Up to now, we have learned the three main ways to solve to find indefinite integration. Okay, so of course for the right hand side, we have to choose integration by parts. By partial fraction. So we have to separate the single fraction into two single fractions. Okay, so it can be written as 1 over x plus 1 minus 1 over x plus 2. Okay, so for the calculation of partial fractions, so I think you may do it by yourself. Okay, so you may make assumption. So 1 over x plus 1 times x plus 2 is equivalent to a over x plus 1 plus b over x plus 2. Okay, and then find the value of a and b respectively. All right, so here the right hand side we can integrate directly. So the first one is ln absolute value of x plus 1, and the second one is ln absolute value of x plus 2, and then plus constant c. Here absolute value plus constant c. But however, we know that x is greater than 1. So it means that this is positive also. So we can remove the absolute value side, which will be ln x plus 1 minus ln x plus 2 plus constant c. And finally, we can combine these two terms together. It will be ln x plus 1 over x plus 2 and then plus constant c. Okay, so finally we made the subject to be y. So it will be y just equals ln x plus 1 over x plus 2 plus constant c, and then over ln x. Okay, so this is one term only. Or maybe you can write your answer as, okay, in your textbook, the answer is, here it is line ln, and here this one can be written as e to the power of c times x plus 1 over x plus 2, okay, over ln x, but it's not necessary. Okay, you may not write the answer in this way. Okay, and this is a constant in your textbook. Okay, so I think you may just write the answer like this. Okay, keep your answer, keep the pattern as this, as this one, or maybe you can also write the answer as ln x plus 1 over x plus 2 over ln x plus c over ln x. Okay, so this is question A. And for question B, now let's look at question B. Question B requires us to find a specific solution. Okay, a specific solution which passes through the point 2, 2. So it means that when x equals 2, y is 2 also. Okay, so let's substitute. So let's do a substitution. So we substitute x and y to be 2 into the equation we find in A. So we have 2 equals the fraction. Okay, so here it is ln 2, and this will be ln x plus 1. 2 plus 1 is 3, and 2 plus 2 is 4, and then plus c. Okay, so finally it will be 2 ln 2 equals ln 3 over 4 plus constant c. And then we here, this one can be written as ln 4 and minus ln 3 over 4 equals c. So combine these two terms together, so it will be ln 4 over 3 over 4 equals c. So finally c is ln 16 over 3. Okay, it's 16 over 3. So finally, the specific solution is y equals ln it is ln